Hello everyone, and welcome to TechnoBoss. I am MacGyver, and today we, to include me, are going to be learning some basic programming and circuitry based on the Arduino platform. The kit that I'm using is the Artist DIY kit that I found on Amazon for $83. Take note, none of this is sponsored by anybody. Okay, I wanted to learn some of this stuff, and this kit looked like it might actually fit the bill. Lesson 6, LED Flowing Lights. Overview. In the first lesson, we learned how to make an LED blink by programming the Arduino. Today, we'll use the Arduino to control 8 LEDs so that the 8 LEDs look like they are following. Hey, we've graduated into multiple LEDs. Woohoo! Requirements. Arduino Mega 2560, a USB cable, 8 LEDs, 8 220 ohm resistors, one breadboard, and 9 jumper wires. Principle. The principle of this experiment is very simple. Make LEDs blink in a desired pattern. Key function, for statements. The for statement is used to repeat a block of statements enclosed in curly brackets. An increment counter is usually used to increment and terminate the loop. The for statement is used for any repetitive operation. It is often used in combination with arrays to operate on collections of data or pins. There are 3 parts to the for loop header: for, initialization, condition, and increment. And here we have for, the parentheses, declare a variable, which is apparently optional, initialize, test, increment or decrement, so increase or decrease. And then we have this print line x, print 0 to 99. Okay. The initialization happens first and exactly once. So that's this part right here. Each time through the loop, the condition is tested, which is the test part, this part right here. If it is true, the statement block and the increment is executed. So this part, and I guess this part down here is the statement block. Then the condition is tested again. When the condition becomes false, the loop ends. Procedures: build the circuit. A whole bunch of LEDs. So it looks pretty simple. Oh, it looks like we might need more than 9 wires. No, we don't, because this is just having the resistors bridge this gap and then bridge again into here. We can just send each resistor straight into the negative line and have each of these LEDs like down here. So this is like super easy to simplify. This looks a lot more complicated than it really is. We're going to do this in a simplified manner when we build the circuit. Program. Oh, we're not doing any global variables. Okay, this is going to be interesting. Let's see how well we'll be able to understand this. Compile and upload to the Arduino Mega 2560 board. You should now see 8 LEDs are lit in a sequence from the right green one to the left, next to the left of the right one, and then repeat the above phenomenon. Oh, see? Look, even here they did exactly what I was talking about. We're going to just having the resistor go straight into the common ground. Let's get started building. So here are all of our components. We have the Arduino. Like always, the USB is off screen. 8 LEDs, 2 red, yellow, green, and blue. We have 8 220 ohm resistors, our breadboard, and 9 wires. Let's get started putting this together. So before I deal with the wires, I'm going to go through and I'm going to start setting all of these resistors. there's our 8 resistors, and now we have our LEDs. And as always, the long one is the anode, the short one is the cathode. And we need it to be the short one in line with the resistor. So we have cathode and anode. And we're just going to go red, then a yellow, then a green, a blue, and start all over again. We're going to be nice and colorful today. Ah! Come back here. There we go. Yellow, green, and blue. Alrighty. So, should all be wired up right. So all what's left is to put wires in on all the anode sides that will connect to the pins. And we got plenty of wires. And it looks like they're having us use pins 1 through 8. So through, and we're going to hook it up down here. The second one. Red, orange. So let's do a yellow one next. Just a full rainbow. See here. Yep. Green. Get in there right. There we go. That's 4 wires. No, wait, we want blue. Purple. Come on, there we go. And, well, we have brown and gray. So, I guess brown next. That's into pin 7, and gray for the last one. That's going to be in pin 8. Then the black wire. So it just has to be anywhere on here, so I'll just put it there, and we'll just run it right to pin 13. Is that right? No, that is wrong. This is also why you do not try to rewire stuff with things with the power on. We got it going to ground. That is the correct one. So we got a nice little rainbow of wire. We got our 8 LEDs, we got our board. The resistor is all wired into the ground. I think we're ready to rock and roll. Let's start programming. So we got the board all set up, time for program. And first thing I noticed, we're apparently not using any global variables. We're going straight into void setup. So let's go and delete this comment. And we're putting in unsigned character LED pin. Okay, LED pin will be set to 1, 2, 3, 4, 5, 6, 7, and 8. It says that a few times. I'm not entirely sure how that works, but well, let's start just jotting it down. Maybe we'll get something figured out. So here, unsigned character LED pin, semicolon. Now this is the for statement that was mentioned earlier. So for parentheses LED pin equals 1 semicolon. LED pin is less than or equal to 8. That's a comma. There we go. That's right. And this is semicolon. LED pin plus plus. I've seen that before. I believe that means just add 1. So it starts out as 1. If it goes through and completes it, then it adds 1 to LED pin, which makes it 2. So now we're at pin 2, and it will just keep on doing that. Okay? Then a semicolon at the end? No semicolon at the end. Pin mode. So pin LED pin output, and this is going to be semicolon. This is the whole setup. Okay, so it looks like we're just putting all the pins to output right now, and we're using the for function. So then instead of assigning each individual pin to output, we're just saying pin 1 through 8 put to output. So let's go down to the loop, delete the comment, the there we go. Unsigned character LED pin semicolon. So this is like we're repeating the first 2 lines of the setup. So in the setup, all we're doing is just setting the pins to output, and here we're kind of using the same code, and we're going to set them to high and low now to get our blink stuff. I'm looking at the code, and it's looking like it's going to go through, turn on all the LEDs, and then once they're all on, then it's going to go through and then turn them off. I could be wrong. Put a comment down below if you think of the same thing or something else. So let's see here. For LED pin equals 1 semicolon LED pin less than or equal to 8 semicolon LED pin. Helps if I spell it capital. Need a capital P in there, and then plus plus. Then curly brackets, because we're not doing the semicolon. And this is where we'll get our digital write to pin high. So digital write LED pin high semicolon. Next line, we're going to delay 200 semicolon, and we're making the next for statement for turning the LEDs off. So we're basically copying the whole thing. For LED pin equals 1 semicolon LED pin less than or equal to 8 semicolon LED pin Come on. There we go. Pin plus plus. Oh, that's equals equals. No, we want plus plus. Then curly brackets. Digital right. LED pin, comma, low, semicolon, delay, 200, semicolon, and that is the entire code. I guess now we get to hook up the board. I'm pretty confident nothing's going to fry. Watch as this is the one time that we release magical blue smoke. Like always, USB cable is first. Well, something's on. Well, we know one LED works. So come here to the code, select the board, verify the code. Oh, did something wrong. What did I do wrong? In void setup, something was done wrong. Oh, right up here. Needs to be a capital P. Re-verify. One little error is all it takes. Upload. Compiling. Oh, I guessed right. Turns them all on, then turns them all off. Okay. Nice and colorful. I like that. So we can speed this up. So if we just change this, you know what? I'm going to do this a little bit smarter. I'm going to put in global variable. int time equals 100. Come down here to the delay. Time verify error expected. Oh! If I'm not screwing it up, I'm not doing it right. Semicolon. Re-verify. It's always something small. Okay? So now this should work. Upload. And then this should speed up. Yep. So 10, verify. This should go a lot faster. Yep, we're going to slow that down. We're going to go back to 200 because that was a decent speed. Okay. So I wonder, what if we do the digital right LED pin low and yeah, let's go ahead and see what happens, and then just delete this section of code. So what I am thinking this is going to do is this will turn it on, then turn it off, and as it's turning it off, it'll then immediately turn the next one on, and that'll be on for the delay of 1/5 of a second. Does this code make sense? The computer says it does. If we upload it, what do we get? So we have a traveling LED. Okay. Yeah, the first lessons are pretty dry and boring, but once you get to here, then you get to really play. Okay. So, and this is part of how you learn. You find the fun stuff, but you got to get through some of the boring stuff. If I wonder if we can do it to where it's going to be 2. So if I get rid of this line right here, and let's go ahead and do the 4 again. Oh, 4 LED pin equals 1. Yeah, semicolon. LED pin less than or equal to 8, semicolon. LED pin plus plus. Yeah, I can probably just copy and paste, but I want to write it out because I want to get a little bit of that muscle memory in. Digital, right, LED pin, high, semicolon, delay, time, semicolon. So let's go ahead and just load this up, make sure that I did this part right. Oh, I did this wrong. Low, verify. All it's doing is just turning it on and on and on. What about, let's do another 4. LED pin equals 1. I did it again. LED pin less than or equal to 8. LED pin. Let's try a minus minus and see what, and kind of see what we get here. And this is going to be a curly brackets. Digital, right, LED pin, high, semicolon, we'll go and do a delay, time, nope, semicolon, there we go. Plus, well, we've been doing plus plus, and I know that's an increment of 1. So, okay, we're just going to do another 4. So, I think this is going to go up one, go down one, go back up one. I'm just going to say delay on this one. So LED pin equals 1. LED pin less than or equal to 8. Semicolon. LED pin plus plus curly brackets delay time semicolon. Okay, I have no idea if this is going to work or if it's going to crash. How does this look? Okay, that says that it's work. Okay, no errors. Upload, what do we get? That's not right. So what if it's minus minus LED pin? Will this work? Okay, it's not complaining. Let's see what we get. Uploading done. Not getting what I was hoping for. Syntax technically isn't bad. Okay, so let's go and just delete. Delete. Okay, go back to so I can do okay, so I still don't know how to let's see here. I want to do the two LEDs, but let's try this real quick. Maybe I'll be able to stumble across something. So, digital right, LED pin, low, okay, and semicolon, okay. So if this one we do 1 and 8 and change this from plus plus to minus minus, then put in high, oops, delay time, then digital right, LED pin, low, semicolon, check for errors, it's good. Then this one should go oh wait. Change that to greater than or equal to upload. Ha ha! Have it going back and forth. Okay. Okay, so what this is showing me is that this loop just keeps going and going and going until it can't go, then this loop goes. Okay, what about oh, digital right? Wonder if this might just completely break it. Plus plus LED pin high semicolon delay time semicolon. Check. Didn't say it didn't like it. What are we getting? Upload. Whoa! What the heck is? It's a result? I don't know what kind of result it actually is. Um. Uh. What? Okay. Well, let's flip this around and see what we get. Hey, a result's a result. Okay, what does this do? Okay, load up. Oh, it's skipping. Okay. So this causes it to skip one, but if the plus plus is before, it won't skip any. Okay, so let's go and go back to this. So what if we were to put a minus minus right here? What would that do? Okay. Oh! I think I did it! Oh! I think I did it! I think I finally figured it out. Okay. Oh my goodness. Okay. Oh, and this is why I tell everybody to continue experimenting with the code. Because when it's like, well, I want to try to do this. And then when you finally figure it out, even if you just stumble across it just by just randomly putting garbage in, it feels so good. Oh, which, let's see here. We got that to do 2. So if I just want to see what, yeah. Okay, so we will, so let's see here. What will happen? And we'll just copy that plus plus LED pin high. Oh, all caps. Semicolon. Okay, let's just see what happens here. Okay. Okay, we're back to the skipping every other one. Okay. Um, minus my. Okay, wait. Okay. So if we say high, go to a new line, digital right, colon, minus minus, LED pin. There's probably a much smarter way to do this, but you know what? I'm having fun and I'm curious. So let's see what this will do. Okay. Okay. So what if we put some delays in here? Delay time. Delay time. Okay, so we now got delays through everything. Make sure that I haven't screwed anything up. Okay, let's see what happens. Oh, that's kind of interesting, especially with the just coming back down pretty quick. Okay, this time I'm actually going to do a copy and paste. Just to see what it will do. Okay. So check the code. Because this is a lot of code. Okay. Okay. The first three seem to be going pretty fast. Okay, so the going out works just fine. But it's not really kicking into this second part. It's all, oh, it's all staying in the first part. Okay. It's not actually kicking out of that. That is okay. Let's go ahead. No, wait, it's just recopying it. So let's go ahead and see here. Control Z. Will that give me anything? Okay. Okay, so let's go and do it to where it's the single one coming back. Okay. Let's see if we can try to get the timing of these first three LEDs to be a lot better. I think an if statement will work. Okay, so we're going to come... So if LED pin is less than 3, curly bracket, delay time asterisk 2. Nope, 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 nope. So another if. I'm just going to copy it this time. Oh, I am going to fix this. There we go. Control C, Control V. There we go. So the first high, the second high, the third high. Will this compile? It does. Let's see what it looks like. Do, do, do. Okay, let's put in another one right here. Okay, so that's all commented out. Okay. Okay, so something's not quite right, and I'm not sure what. So if we get rid of this, upload, doop, 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 doop. Okay, and light, 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 light. I don't know. That just seems like it's a little off for some reason. What if we get rid of one more? Because maybe the first one's all we needed. Oh. Okay, obviously not. Put that back in. Maybe. Oh, what if we say 2 on both of these? Let's see what happens. Okay, what about that? Mm-mm. What about that? Let's see here. Nope, nope, nope. So times 2 is needed. Hmm. One, two, three, four. One, two, three. Hold on. Okay, so what if we were to times 3? Oh, we have a little bit of a different result. Two, two, two. Okay. 1, 2, 3, 4. 1, 2, 3, 4, 5. 2, 3, 4. So, okay, so we got a delay between the third and the fourth LED coming on. Okay, what if we were to change that down to 2? What would that do? Oh, nope. So, 2, 2. So, let's see if we can figure this out. So, the third one, it lights up. What if we change this one to 2? Five, 6. Yes, okay, I got rid of the anomaly. Okay. So, oh, I've got so much editing to do on this. An hour. Oh. Well, aside from fears of editing, this looks really good. Thank you for joining me in this lesson. If you like what you see or found this video helpful, please like and subscribe. Click the bell icon if you would like to be notified of new videos when they come out. I can do this, and so can you. Until next time, good luck, have fun, and stay curious.